Hello everybody, welcome back to week 3 of distance learning. If you are watching this video, you should have already watched my previous video on ratios. You might have reviewed the notes that I uploaded with some examples, and you should have completed the quizzes assignment on ratios. So now that you know what a ratio is and how to write and read ratios, we are going to be learning about equivalent ratios. Now, this word equivalent is one that you should be very familiar with because we've been talking about equivalent fractions in class all year long. So firstly, let's review what a ratio is real quick. We know that a ratio is simply a comparison between two different quantities. It's just a way to compare two amounts of something or two quantities that could be of different things or of the same thing. We use 3 different symbols to write ratios. We can write a ratio with the word 2, with the ratio symbol, which is a colon, or we can write it like a fraction. This last part, the fact that we can write it like a fraction, is going to make understanding equivalent ratios really relatable to what we've already learned in class about equivalent fractions. So when we write a fraction, our fraction is written as a part over a whole. For example, if I have the fraction 1/2, I have 2 whole things and I have 1 part of that. Now, what are some equivalent fractions to 1/2? If I have the fraction 2/4, I have 4 whole things, but just 2 of them. Notice that 2/4 is visually equivalent to 1/2, and y'all have shown me in class that if you have the fraction 2/4, you can simplify it because you know that 2 and 4 have a common factor of 2. The greatest common factor is 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Therefore, 2/4 is equivalent to 1/2. It can be simplified to that fraction. Now, there are more fractions, equivalent fractions, that we could come up with. The next one that I think of is maybe 3/6. We know that 3 is half of 6, so we already know that this is an equivalent fraction, but let's draw it out and see. So if we had 6 whole things, so 1, 2, 3, 4, 5, 6, but then we really only have 3 of them. Again, visually, you see that this is the same fraction here. 3 and 6 share a common factor of 3. The greatest common factor is 3. 3 divided by 3 is 1. 6 divided by 3 is 2. It's an equivalent fraction. So we know what equivalent fractions are. We understand how to simplify them. And it's important that we get this because this is going to translate into our understanding of equivalent ratios. So when we write a fraction, it's always a part to a whole. When we write a ratio, we could write it as a part to a part, a part to a whole, or a whole to a part. And since we can use all of our symbols, the word 2, our ratio symbol, which is the colon, or write it as a fraction, we can write ratios as a part over a part over a whole, like a fraction, or a whole over a part. All we are doing is comparing 2 quantities using division. Now, we are going to get into how to determine if ratios are equivalent. All right. Let me draw all right, I have 3 stars and I have 6 circles. So you might see a question that says, what is the ratio of stars to circles? And you would tell me, oh, Miss Herbster, the ratio is 3 to 6. There are 3 stars for every 6 circles. We could also write that as the fraction 3 over 6. There are 3 stars for every 6 circles. Now, maybe somebody else comes in and they have 1 star and 2 circles. Maybe I say, is this an equivalent ratio? So previously we had 3 stars to 6 circles. Now we have 1 star to 2 circles. All right, so visually first, let's redraw our drawing at the top so that we can see these stars. Got 1, 2, 3, and now so we can see these circles. 1, 2, 3, 4, 5, 6. If I draw my collection of stars and circles like this, I see that I have 3 stars to 6 circles, right? But I could also group them into equivalent groups. And here we see that for 1 star, there are 2 circles in each of these groups. Now, this tells me that within my collection, for every 1 star, there are 2 circles. So even though total I have 3 stars and 6 circles, the ratio 1 to 2 is equivalent to the ratio 3 to 6. You could check this in a couple ways. Now, one way that I think many of you will feel very comfortable with is by writing your ratios as fractions. And the question is the ratio 3/6 equal, is it equal to the ratio 1/2? Well, there's a couple things that we can do. There are many methods for checking this, but these are the 2 methods I would really recommend. Firstly, if you write it like a fraction, all you have to do is simplify your fraction. The greatest common factor of 3 and 6 is 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Does 1/2 equal 1/2? Yes, these are equivalent ratios. Now, another way that you can do this is by writing your ratios as fractions. So again, we had 3 blue stars to 6 red circles. And we're wondering if it's equivalent to 1 blue star for 2 red circles. All right, so we can multiply the cross product. That means multiply going across like this, and we'll see what we get. When we do 3 times 2, we get 6. When we do 6 times 1, we also get 6. Since 6 equals 6, we could say, yes, these are equivalent ratios. All right. Now, I want to do one more example with you so that you understand finding equivalent ratios. I think that one of the best ways to understand equivalent ratios is to think about how we use them in the real world. And one of the most common places that you're going to use ratios are in recipes, when you're cooking, baking, when you're making something in the kitchen. So I'm going to use a problem that was on your district packet. So if you're following along, this is 3.2, the powdered drink mix. So what we are doing here is, imagine like you're making a juice mix, Kool-Aid, something like that, okay? So in order to make this powdered drink mix, we are going to use 4 teaspoons of drink mix. And we're going to use 1 big cup of water. All right, so our ratio is 4 teaspoons for every 1 cups, or 4 teaspoons of the mix for every 1 cup of water. Now, maybe you wanted to make a larger batch of this mix. Maybe this is just enough for like 1 small glass, and you want to make another so that you could share it with your brother. Well, if we're going to make 2 of these, we're going to double everything that we're making. So instead of 4 teaspoons of mix, we're going to have 8 teaspoons of the mix. And instead of 1 cup of water, we're going to have 2 cups of water. Now our ratio is 8 to 2. But even though these numbers are different, our drinks are going to taste exactly the same because these ratios are equivalent. My first ratio was 4 to 1. I'm going to write it as a fraction. My second ratio was 8 to 2. I'm going to write it as a fraction. And the question is, are these equivalent? Well, 8 and 2 have a common factor of 2. 8 divided by 2 is 4. 2 divided by 2 is 1. And we get the ratio 4 to 1. So even though we have changed our ratio, it is still equivalent to the original ratio because we multiplied both amounts by the same thing. We multiplied our number of teaspoons by 2. We multiplied our number of cups of water by 2. So something you could do, which is especially helpful, let's say you were going to have a big family reunion or a big party or something, and you wanted to make a huge batch of this mix. So we could actually make a table of values here. And we have our teaspoons of the mix, and we have our cups of water. All right, so if we're gonna make just 1 normal batch, let me draw these lines real quick. If we're gonna make 1 normal batch, we have 4 teaspoons of mix, 1 cup of water. If I make 2 batches, I'm gonna multiply everything by 2. So I'm gonna use 8 teaspoons of the mix, and I'm going to use 2 cups of water. If we make 3 batches, I'm gonna multiply everything by 3. 4 times 3 is 12. 1 times 3 is 3. So to make a larger batch, or make 3 batches, I would have 12 teaspoons of the drink mix and 3 cups of water. And we would continue this for as long as we need until we have the ratio for whatever size party we're going to have or whatever. 4 times 4 is 16. 1 times 4 is 4. 4 times 5 is 20. 1 times 5 is 5. 4 times 6 is 24. 1 times 6 is 6. 4 times 7 is 28. 1 times 7 is 7. So all of these ratios here are equivalent to our original ratio. We just multiplied our original ratio, both parts, by the same amount, in order to keep it the same. So each of these, even though we're getting bigger and bigger batches of our drink, they're still going to taste the same because they have the same ratio of teaspoons of drink mix to cups of water. All right, so once you complete this video, you need to complete your second quizzes assignment, which is on equivalent ratios. And then your last thing that you need to do for this week is just complete the short Microsoft forms that I posted in our Teams. If you want more help with this, if you're struggling or finding it kind of challenging, please join me during office hours. My office hours are every day from 1 to 2 p.m. If you want to send me a message on Teams or text me and remind, send me an email, that's also fine. I will get back to you. I hope you guys are doing well, and I hope this makes sense. I miss you very much. Remember, make the rest of the day the best of your day, and I will see you soon. Bye.